Yes. So we have discussed direct form structure of FIR implementation and also cascade structure and lattice structure. So we have seen the lattice structure in detail, that uh, what are the relations between coefficients of lattice structure and the coefficients of direct form structures. So we have seen some examples. So if lattice coefficients are given, then how to calculate the direct form structure, and if direct form coefficients are given, then how to calculate the lattice structure. This you have understood?
Yes, sir.
Okay. So you just go through the examples that I have given. Now, we have earlier discussed the IIR structure implementation for using different methods like direct form, cascade, parallel, ladder. Okay. Now, the lattice structure can also be used in implementing the IIR systems. What is the difference between FIR and IIR system is that FIR system is all zero system. Okay, only the numerator polynomial exists in the system function. No denominator polynomial. So if it is numerator polynomial, then only zeros exist. Whereas in IIR system, both numerator and denominator polynomial exists. But mainly it is a recursive system. So the numerator polynomial may be only equal to 1. That represents the xn only, no past values of input xn. But importantly, it consists the denominator polynomial that represents the poles. So it is a all pole structure mainly. So only if denominator polynomial exists, if only denominator polynomial exists, then all values of roots are poles. So it is a all pole system. So this is the difference between FIR and IIR system. Now, in describing lattice structure, okay, for IIR system, we consider a system function Hz that consists of only denominator. You can see it is written h of z is equal to 1 upon 1 plus summation k is equal to 1 to n a n k z to the power minus k. So that is equal to 1 upon a n z. A n z is the representing the denominator polynomial of order n. So as the order changes, the denominator polynomial will also change. As you have seen in the case of FIR system, it was ANZ, okay, and for or AMZ for different order of M, we have seen different polynomials arise. Okay, so here the same situation, but it is in the new denominator side. So if this is your system, then if you take the inverse Z transform of it, then you will get the IIR system as Yn is equal to this one. Okay. Summation k is equal to 1, k is equal to 1 to n, a n k y n minus k plus xn. This is coming from where? It is coming from hz is equal to yz upon xz. So yz by xz is equal to 1 upon 1 plus this summation part. Now if you take left hand, multiply left hand side, okay, and right hand side, cross across the equation. So then yn, then it will be multiplied with z to the power minus k. So in z domain, it is multiplied with z to the power minus k. So in time domain, it will be y of n minus k. And xz inverse z transform is x of n. So this is the equation. But if you want to represent it in lattice form, okay, lattice form is what? It is a delayed version of input. That main concept is the signal flows from input to output side through different delay stage of input. One delay, it is xn minus 1, another delay xn minus 2, like that. But now in this equation of yn for IIR system, if you replace yn with xn and xn with yn, then what situation arises? That in place of yn we write xn. So xn is equal to summation k is equal to 1 to n a n k x of n minus k plus yn. So it is actually again resembles to FIR system. Okay, but the structure is FIR system. But what important thing is that we have interchanged the input and output within themselves. So this yn now, okay, is equal to xn plus summation k is equal to 1 to n a n k x of n minus k. This equation. Now, if in the top side you see one figure that xn, the direct form realization of all pole system. Okay, all pole means there are feedback. Okay, feedback from output to input. So it is a recursive system. Okay, IIR system is recursive system. So output, the first stage output yn is delayed yn minus 1. Then it is multiplied with an1. Then yn minus 2. Then it is multiplied with n minus 2. Like that, if you go on adding the different delayed version of output, and then if you add those, okay, add those and further add with input xn, okay, according to this equation 7.3.27, according to this equation, okay, it will be implemented as this structure. It is direct from one structure. Okay, directly the delayed versions are taken and added, but here output is fed back to the input. Whereas in the FIR system, input is taken, is applied to different delay stage, so that we got x of n minus 1, x of n minus 2, like that. Now, what it is written, that we note the equation 7.3.2 describes the FIR system having the system function hz is equal to anz. Okay, simply it is a transfer function containing the numerator. Okay, it is simply hz is equal to anz. while the system described by the difference equation 7.3.27, it is representing an IR system with system function Az is equal to 1 upon ANZ that we have started with. Okay? So it is coming from there. So one system can be obtained from the other simply by interchanging the roles of the input and output. Based on this observation, we shall use the all zero FIR lattice described in previous section to obtain a lattice structure for an all pole IIR system by interchanging the roles of the input and output. So what we realize that all zero system is basically a FIR system where only numerator polynomials. All zero system is basically IIR system. Okay? All pole system is basically IIR system where only denominator polynomial is there. Okay? So FIR can be converted to IIR or IIR can be converted to FIR provided if you change the input by output and output by input. So now let us define input xn is equal to one function fn of n and the output as final output yn is equal to f0n. Okay. Earlier in FIR system we have assumed that xn is equal to f0n. If you remember it, xn is equal to f0n. That is the first function, initial function. But since we have interchanged the role, so the last stage output function is fn, that actually termed as xn, and the first stage output f0n is termed as output yn. Okay, so it is a feedback type of system. So the flow would be from output to input. The flow of lattice structure would be from output to input. Okay. So whereas the FIR system was flow from input to output. Okay. Now this definition dictates that the quantities Fmn can be computed in the descending order. That is, first you know Fnn, then Fn minus 1n. So you have to need to know Fnn to know Fn minus 1. To know Fn minus 1, you need to know Fn minus 2. Like that, it is a reverse order system. So you can write that f of m minus 1n is equal to f of mn minus km gm minus 1 n minus 1. Okay, so this means that output of one stage, okay, is what? Let us say fm minus 1n. Okay, this is the first output, is fm minus 1n, let us say. Now it is dependent on it is not dependent on previous stage, it is dependent on its subsequent stage, that is subsequent stage outputs, that is fmn, because feedback is considered. So fm minus 1n is equal to fnn, fmn, and minus km gm minus 1 n minus 1. Okay. So gm minus 1, earlier it was also there, gm minus 1, but it was delayed by 1 unit. So here also it is delayed by 1 unit. Okay. So now you see the structure. Okay. So basic all pole IR structure. You can see here that, see it carefully, that output is yn this side, and it is assumed as f0n. Okay, and this is going to the input side. Okay, whereas in the FIR system, this arrow is coming from output, input to output, but this arrow goes from output to input. Okay, and here negative sign is there. Okay, so initially, so here also reflection coefficients are k. So the this output f0n is multiplied with k1, and g0n is delayed and multiplied with k1. This operation is same as the FIR case, and these are added. Okay, but this one f1n is subtracted. F1n is obtained as, according to this equation, fm minus n minus km gm minus 1 n minus 1. Okay, so this way it is calculated. So this is the structure. So once we get the output f1n and g1n, okay, from the next stage, from the last stage, then they are again fed back to the given to the input side and multiplied with the next stage coefficient k2. Okay, and similarly they are calculated, and the first stage you see the output as x of n and gnn. Okay, so two inputs. In each stage there are two inputs and two outputs. But you see the flow, actually this is, although the output is, there are directions from input going to the output, but also at the same time direction is there, flow is there from output to input. Okay, so this f1n is actually calculated as f1n. Let us consider that the first stage f1n and this so let us consider the case where n is equal to 1. Okay, so what are the equations for n is equal to 1? Xn is equal to f1n and f0n is equal to f1n minus k10 n minus 1, according to this equation. If it is f0, then it should be f1. So if it is f0, then it is f1, then it goes as minus k1 c0 n minus 1, then g1n k1 f0n plus g0 n minus 1. So this yn is equal to f0n. Okay, so this actually expressed as g1n. So here so we have, as we have discussed, that the final stage output should be considered as x of n. Okay, that is, if n is equal to 1, then f1n is equal should be x of n. So like that, if you calculate, okay, all the structure stages, then you see that one stage for n is equal to 1, this is nicely given, a single pole structure where n is equal to 1. Okay, so output is yn is this one. Okay, now it is considered as f0n and g0n. Okay, and uh, the this f0n is multiplied with k1n, k1, and g0n with delay multiplied with k1, and we get f1n. f1n is equal to what? f0n f1n is equal to f1n. f0n is obtained from f1n. Okay, f0n is obtained from f1n. So f1n is there, and f0n, how it is obtained? It is obtained from f1n minus k1 into g0n. Okay, f1n minus k1 into g0n minus 1, because delay is there. So this f0n is obtained as this way, but it is taken, the feedback is also taken at the same time. Then again g1n is g1n is what? g1n is addition of these two functions, f0n, okay, plus f0 k1 into f0n, okay, k1 into f0n plus g0n minus 1 plus g0n minus 1, no multiplication with constant. So you have to remember this structure formula. Okay, so in the in the diagram, you see the direction of signal flow in the top path. Top path signal direction goes from left to right. Okay, but in this direction, okay, it is forward direction path, but in the lower path, the signal direction is reverse. Okay, it goes from output to input side. This thing you have to remember. Okay. Then this is for single pole system structure. Then two poles lattice structure, lattice FIR structure is this, that f0n, the previous first stage is same. Then first stage output g1n is passed through this delay. Okay, and f1n is again taken and it is multiplied with k2. So f2n is equal to f1n is equal to f2n minus k2 into g1n. Okay, so this way it satisfies the equation. Okay, now these are considered for two pole system. Okay, so there are two functions, f1, f2, f1 and g2, f0, g1, like that. So this is the structure for lattice FIR implementation. Now another structure is that is called lattice ladder structures. Okay, both lattice and ladder diagram, lattice and ladder structures are used, okay, for a both pole and zero system. Both the poles and zeros are are there, okay, and in general IIR system both poles and zeros are present. So it consists of both numerator polynomial and denominator polynomial. You can see it is written that it is numerator polynomial is CM k z to the power minus k, and denominator polynomial is 1 plus k is equal to 1 to n an k z to the power minus k. So it is called CMZ divided by ANZ. So how it is implemented, that HZ is assumed as numerator expression of HZ. Okay, it is YZ by WZ. Okay, as we have done in the case of direct form structure, we have considered separately the numerator and denominator. So YZ numerator expression of HZ. So YZ by WZ. Okay, this is one expression, and WZ by XZ, this is another expression. Okay, so uh, this Wn can be considered as, if you take the inverse Z transform, okay, there we'll see that WZ by XZ. Okay, WZ by XZ, it represents the 1 by denominator polynomial, only the denominator expression. So that means WZ by XZ is equal to 1 upon 1 plus k is equal to 1 to n an k z to the power minus k. Okay, this represents the denominator expression or WZ by XZ. Now if you take the Z transform, inverse Z transform, then it will come, this equation will come, Wn is equal to minus ank Wn minus k plus xn. Okay, and if you take the other numerator expression, that is only summation Cm k z to the power minus k, it is actually equal to yz by wz. So if you calculate yz inverse z transform of that, so it is only numerator expression, and only say it consists of only it represents an FIR system. Okay, so only zeros are there. So since zeros result forming a linear combination of previous outputs, we can carry over this observation to construct a pole zero IIR system. Okay, pole zero IIR system using the all pole lattice structures as the basic building block. So we have already observed that GMN is a linear combination of present and past in outputs. So in fact, the system is an all zero system. So just going to the mathematics here, let us think that there is some intermediate stage, okay, Wn, in between yz and xz. So uh, we see that the structure, the lattice ladder structure, both the ladder lattice structure and ladder structure are implemented. So the top one is the lattice structure, but for the expression yz wz by xz, that is the all pole 1 upon 1 plus summation a n k z to the power minus k. So it is representing all pole system, and it is a lattice structure we can implement over there. So here we write this way, that signal flow goes from output to input, okay, but in the forward uh, top path, upper path, the signal flow direction is forward, but in the reverse path, signal direction is backward. Okay. Now this G is considered, you see, that different delayed version. Okay, different delayed version. So here uh, we, if you analyze this, you will get Gn. You will be so the other part, actually other part is this one. Okay, that is Yn is equal to k0 m, k is equal to 0 to m, and it goes from cmk k is equal to 0 to m, and cmk, which is a coefficient, wn minus k. Okay, so this wn minus k, it is actually different delayed versions of w. So this w is actually equal to where it is, yes, w is actually equal to g. So different G is there, it is already delayed, different delayed version of G is there. So G0n, so G0n goes to this one, Z inverse, then it becomes G0n minus 1. Then again we get G1n. So, and again it is delayed. So here some calculation is there. You can see that we add a ladder part. We add a ladder part by taking as the output a weighted linear combination of GMN. And this represents the zeros of the system. So anyway, this is basically the lattice ladder structure that I wanted to show. Okay, now then analysis is how it is performed. Then it is slightly they have explained. You just go through this structure and read it thoroughly, then you will be able to understand and try to see some examples, okay, of this lattice ladder structure. Anyhow, we have discussed the different parts of lattice structure. So you may, if you have any doubt, you can ask now, and your other topics, some topics are remaining in for this module, okay, like related to coefficient, round off or quantization effect. Quantization effect is remaining for this second module. Okay, but if you go through it, it is not that you will not understand, but it is slightly in advanced topic. Okay, and it is not in your syllabus. But anyhow, I have mentioned that thing in your class notes in the PPT. You can go through it because you have to implement both lattice and ladder structure to realize both poles and zero systems. A system if contains both poles and zeros, then if you want to implement ladder structure, then it cannot be used alone. So if you want to implement a lattice structure, so it cannot be used alone. You have to take help of ladder structure because both numerator and denominator polynomial are there. Okay. So to implement that, so that means numerator is implemented using ladder structure and denominator is implemented with lattice structure. So this way it is done. That's why it is called lattice ladder structure. So okay, today I am stopping now.
Sir, excuse me, sir.
Yes.
Sir, from where can we practice numericals on this?
Numericals, see the mostly I have given all the many numericals related to almost all the topics, starting from direct from 1 to cascade.
Yes.
Okay, parallel, those numericals are sufficient to understand.
Yes,
But
sir.
for lattice also I have given some numericals. Okay, that how to convert the coefficient direct from coefficients to lattice coefficients and vice versa. So that can be done easily, but that examples are not very much available, okay, for this lattice ladder structure. Okay, up to lattice structure you can get the numericals, but for lattice structure, but lattice ladder you have to search quite search lot for this. But from all the previous topics, the numericals are sufficient that are given in the notes.
Yes, sir. Thank you, sir.
Mm. Or if you see some numerical, then you can ask me, I will solve it. No problem, no issue. I'll be happy.
Yes, sir.
Okay. So by then, okay, then I stop here.